Molar mass. We learned about atomic mass, right? Atomic mass is the mass of what? An atom. The molar mass is the mass of 1 mole. Okay? Thanks for closing the door. The molar mass of a substance is sometimes abbreviated capital M, is the grams, the mass in grams of 1 mole of the particles. So for an element, it's the atomic mass expressed in grams. For a compound, it's calculated the same way you calculate a formula mass by adding together the masses of each element that are present in 1 mole of the compound. So let's do some examples. Calculate the molar mass of sulfur hexafluoride. Sulfur hexafluoride is SF6. So in 1 mole of sulfur hexafluoride, how many moles of sulfur are there?
1.
Just 1. The coefficients are what give us this answer. We don't write 1s because chemists don't like the number 1, but there is a 1 there. So we have 1 mole of sulfur. Well, how much does 1 mole of sulfur weigh? 32.07 grams. And then we also have how many moles of fluorine? 6. And fluorine, each mole of fluorine weighs 19 grams. So then we've got 32.07 plus 6, that's not a 6, 6 times 19. And we come up with 146.07 grams. And that is equal to 1 mole of sulfur hexafluoride. That's a good question. What about significant figures? Usually how we deal with significant figures in molar masses is we look at how many sig figs did each of our numbers have, and we'll round accordingly. And so this one had 4 and this one had 4 because I'm using the periodic table in my brain that I memorized from a previous book that has 4 digits, 4 sig figs for each molar mass. So then you would round this off and call it 146.1 grams is equal to 1 mole. Usually calculating the molar mass is a step inside of a larger problem, and so it's not your final answer. If it's not your final answer, you really don't want to round it off. You're better off keeping the extra digits because they'll never end up being enormous because we're just adding things together. We don't end up with 9 decimal places after the decimal point. That's a good question. And sometimes you'll see this written, here I'll round it, 146.1 grams per mole. That's the same thing, isn't it? Grams per mole or grams, this many grams equals 1 mole. How about the molar mass of strontium acetate? And here's the formula. We're going to use the formula. There's 1 strontium. How many carbons? 4. Because inside the parentheses there are 2, and there's a 2 on the outside, so that multiplies everything. So we've got 2 carbons, 6 hydrogens, and 4 oxygens. So strontium is at 87.62. Can't quite see that one. So 87.62, and then 4 carbons, 12.01, 6 hydrogens, 1.008, and 4 oxygens. Now, when you look at different periodic tables, they may have different numbers of significant figures listed on them. Most of these we know to more than the listed number of significant figures, but just use whatever periodic table you have. Use all the digits that it gives you. Okay, let's add this up. 87.62 plus 4 times 12.01 plus 6 times 1.008 plus 4 times 16 equals My calculator says 205.708. And if I was going to use this in a calculation, I'd want to include the extra digits, but otherwise I would most likely round this and say it's 205.7 grams, equal to 1 mole. There's different ways of thinking about it. If you think about, well, I'm just adding all these numbers, then you'd end up with 2 decimal places, right? What happens normally in calculations that students have to do is we often just give you data of 3 sig figs. And so however you do your molar masses with 4 or 5 or 6, it ends up being more than is needed. So we're not going to make a big deal out of rounding molar masses to the correct number of significant figures, because at the most you're probably going to end up with 2 or 3 extra ones, and so it just really doesn't matter that much. But it's good to think about. Now, I really encourage you when you're doing a molar mass to write this down. Write down the masses of each element and how many moles of each, and do that calculation on your calculator twice, because there's a lot of digits to push in and it's easy to make a mistake. So I encourage you to show your work there. Any other questions?
I have a question.
Mm-hmm.
Is this PowerPoint up on the Blackboard yet?
It should be. I was pretty sure I put all of them up for the whole semester. Yeah, look again, because if I didn't, I should have. Yeah, I forget so many things. What's the molar mass of nitrogen gas? Well, this is an element, right? So under nitrogen on the periodic table, it says 14.01 or something similar. Is that the molar mass of hydrogen gas? I'm sorry, nitrogen gas? No, because it's a diatomic element. All right, nitrogen gas has the formula N2. So we need to multiply this by 2. The molar mass of nitrogen gas is 28.02 grams per mole. That's another way to write it. It means exactly the same thing. So those 7 diatomic elements, we need to remember that when they are by themselves, their formulas have a 2 subscript. Do you want to do one more, or are you good? Do another one? Okay. Determine the molar mass of ammonium phosphate. Here's the formula. So we look at the formula, and we've got nitrogen, hydrogen, phosphorus, and oxygen. We need to figure out how many of each of them, because in 1 mole of this compound, we would have 1 mole of nitrogen times 3. So 3 moles of nitrogen. We look up nitrogen on the periodic table, and how many moles of oxygen? I'm sorry, hydrogen. 3 times 4, 12, right? And that's another reason why it's good to write this down, because then you can go back and check yourself. Oh, did I do that right? And then how many phosphorus? 1. And how many oxygens? 4. Three times 14.01 plus 12 times 1.008 plus 30.97 plus 4 times 16 equals 149.096 grams. So 149.1 grams per mole. Do not round your molar masses for the elements any further than 4. Don't use any less than 4 significant figures. Don't round 14.01 to 14. Don't round this to 1. Don't round that to 31. With these particular elements, it's not going to make much difference. But with things like chlorine that are 35.45, That's almost right between 35 and 36. And then all those rounding errors can add up and mess up your answer. Any questions?